This is the original hospital. Is this got okay? Yep, here we go. So this is the older complex. Just down in here, you can see the old boiler plant, the old boiler house. The new boiler house is out here now. A lot of this portion of the hospital here has now been demolished, and the new hospital stands in its place. So this was back in 2013. So these are the existing coal-fired boilers. That they're actually still there. They were installed in 1964. So the load on site changed considerably between winter and summer. So obviously the heating load was much higher in the winter. Coal was becoming more expensive, and the decision was made to look at alternatives. So the Burwood Hospital was first cab off the rank with a major investment, hospital redevelopments in Canterbury. I'm told $1 billion. It's also the largest, the Burwood project was also the largest government rebuild project in Christchurch East. The entire hospital spend was $215 million. They took some of the, capacity from another hospital and combined that with the new Burwood Hospital. So the new Burwood Hospital houses 230 new inpatient beds. And I think, the other stuff's pretty standard. You know, you get TV, Wi-Fi, and there's nothing groundbreaking about that. But yeah. So in 2014, the project was awarded to Polytechnic Biomass Energy, and the project involved the supply of steam and low temperature hot water. The extent of the works involved 3 boilers. So there was a 4 megawatt biomass fired boiler, a 2 megawatt biomass fired boiler, and then a 4 megawatt diesel boiler for emergency security of supply. That boiler only ever runs if for whatever reason there's an issue with fuel supply or a breakdown, or so it was the security supply. That's all it's there for. It's actually kept hot by the biomass fired boilers, so should they lose steam via the biomass fired boilers, the diesel boiler will kick in immediately and cover the steam requirements for the hospital and hot water. This is just a photo of the typical fuel streams that the boiler plant's running on. So we've got bark and hog fuel. I class them as a lower cost fuel. It's not a high quality wood chip. Quite a high moisture content. What Christian's trying to illustrate here is the diversity, I guess, of a well-designed boiler plant being able to handle varying fuels of varying calorific value and moisture content, and a high utilisation of the plant. Some of the fuel can be quite ugly depending on how well it's screened. The fuel here is quite good, but the Polytechnic boiler plant are capable of handling oversized fuel. So in an instance where some biomass fired boiler plant will have an issue with a jam conveyor or a rotary valve, the fuel handling system here is quite a bit different. It's the conveyor is a hydraulic system. It pushes the fuel in rather than conveys it via a conventional screw conveyor is not used. This is the boiler house development here. So we have the entire boiler house. There's 2 live floors, one for each boiler. We have the 4 megawatt biomass boiler here, 2 megawatt here. We have a a deaerator here, and this is a electrostatic precipitator here, and there's the 4 megawatt diesel boiler there, and a nested stack which has the 2 biomass-fired boilers sharing one stack and the diesel boiler sharing the other. Control rooms down in this corner. This is just a shot from the other side. We've got a diesel generator here for emergency power supply should the power supply to the boiler house be lost. So in the event of a power outage, that generator will kick in and the plant will continue to run. So this is the boiler house from the outside. It looks, well, these are the architect's images, but it looks pretty much exactly like that. The building itself is quite elaborate and reasonably expensive, but I guess so. I'm trying to make it look as soothing to the eye as I could, so that probably cost more than it needed to, but essentially it's a functional boiler house. So this was during the installation of the plant. You can see up here the hospital going in. So this was back in March 2015, and you can see down here the existing boiler house, and just to the right is the foundation for the new biomass-fired boiler house. This here, being a hospital, it had a high importance level, so it meant that the design standards that the plant was built to were much higher than they would be if it was just a processing facility. So that affects everything from the foundations right through to the boiler plant and all the piping and the forces that the plant's subjected to are much higher. So you can see, you can see here there's a phenomenal amount of reinforcing going into these plants. You can see the modular furnace in the back there. That's the bottom furnace module. Some of the loads are quite high. These furnace modules are heavy. This is the first one going into place. Actually, that's the first one there, 2 meg there. This is 4 meg here. So they get stacked. There's 3 modules sit on top of each other. There's another intermediate module here, and then the boiler sits on the top. This is the nested stack here. This is the electrostatic precipitator that cleans up the flue gas. You can see the boilers are going here, the 4 meg, the 2 meg, and then this is a flue gas economizer, so that's used to recover waste heat from the exhaust gas and use it to preheat the incoming water into the boiler, just to maximise the efficiency. We have a multi-cline here, which helps to separate out any particulates, and then an air preheater here, which preheats the underground air going into the boiler, just assists with the drying of the fuel and combustion. So this is the boiler house starting to come together here. Unfortunately, the construction of the actual boiler house was outside of our scope. We had some quite major delays early on with the boiler house, so that had a knock-on effect really, and the completion date as a result was pushed back. This in here you can see these are there's a lot of refractory and bricks and bits and pieces here that are installed into the furnace modules. That had to be done on site, just given the actual high furnace loads. The sheer weight, the units couldn't be shipped as a module. They had to be shipped empty and then bricked out on site. So this photo here was taken sort of November, December last year, so the roof and the walls are just going on. This is showing the building, just the cladding's all but finished. there was a lot of trades in there. There was electricians, plumbers, engineers, pipe welders, and obviously the building construction work going on. So our team alone, we had up to 30 on the job. So this photo here is taken around commissioning. You can see here we've got the top of the deaerator here, electrostatic precipitator here, diesel boiler down in here, 2 megawatt biomass boiler here, and the 4 megs up the back. So there's approximately 30 kilometres of cable on the job. It's about a kilometre of pressure pipe work, 2,500 pressure pipe welds, subjected to 10% radiography. And under the Becker contract, if we had a weld fail radiography, we had to do 100%. So it was really important that the quality was managed well. So the outcome is we had a successful outcome. The plant runs unattended. The plant also automatically adjusts to the fuel that it's being fed. So if the moisture content goes up or down, or even the fuel changes, a high percentage of bark or a high percentage of whole fuel, the plant will automatically compensate. So there's no manual intervention. So this photo was taken during commissioning. So that fuel's approximately 45 to 55% moisture content. So it's whole fuel and bark. We ended up finishing the plant, and the hospital was behind with their steam system. So we have a containerised steam dump, which allows us to dump processed steam to atmosphere. So we used this during the commissioning process to generate load, and we could pretty much dial up any load we wanted, which was a benefit during the emissions testing, because we could test right through to the maximum continuous rating of the plant without any issue with not having enough load. So the results of the emissions testing was very good, but I mean it was no surprise. The consented requirement was 50, and we come in at 8.5 on PM10, and the suspended particulates were at 1.2 kg per hour. Sorry, that was the requirement, and we come in at 0.09. So the result is the new hospital is now heated with 100% renewable energy, and handover was just of late, actually, just June 2016. It's just a typical photo of what you can find in the fuel bunker. You see it's not blended, it's just dumped on the floor. And this is a shot of the hospital there. You can see the new energy centre in the background there. And this is the new hospital right through here.